Hello students, welcome back to your computer science class. So I had told you all I will show you all the program where you have to find out if it's a consonant or a vowel. So in this in this program, I am taking a variable called alphabet that takes an input from the user where I tell the user enter an alphabet, and I am not converting this into integer type. So it is not int input. It's only input. Now, after taking that input, I am going to find out, I'm going to use conditional statements. I'm going to find if it is a small a or it's a big A. And then if it is, then I'm going to print that the alphabet is a vowel. Again, similarly, I will check for small e or big E, small I or big I, small o or big O, and small u or big. If it's none of these, it will become a consonant. Okay, so this is an if else program. Now I'll show you all one more program. Okay, I'll run this and show you all too. Okay, the error over here is I have used the wrong variable name. Over here it should be. Z is a consonant, but over here this ends. What if I want to do it in a way that it keeps going on and on till the user decides to stop? So I will use my while loop. While true, T has to be capital. And I'm going to put all this inside the loop. Okay. And I'm going to say press 0 to escape. Now, if the person has put 0, then it will be an integer. Correct? So over here, I'm going to put one more, going to say if, I'm going to say if integer, change the input, change what you get into an integer and check equals to 0, then I will say break. Let's try if this will run. 6. No, let's put F. Alpha is not defined. Oh, spelling mistake. Yes. Okay, so maybe I take another escape equals to integer. Why? Okay, basically, you cannot convert it into integer type like that. So what I have done is rather the old trick where I have said enter an alphabet and I'm writing press 0 to escape. And first and foremost, I am checking for 0. So I'm saying if the alphabet written by the user is 0, break. So it will come out of the loop. Or, and then elif, 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 and finally consonant. Now let's run this and see. So the consonant, wobble, wobble. Finally 0. I've written 0. This is O. This is O. And I'm writing 0. It's an exit. Okay. So this is how you make a loop that the user can exit whenever they want. All the programs that you all do should have this so that you have a user control. The control you give to the user, how many times they want to run the loop, they can. You just have to be smart in knowing where you have to check, in the beginning or in the end. Okay. All right. So that this was the program I had told you all to do. Now let's see one more program. Whichever program allows you to use functions, you should use functions over there. Okay, this is a Fibonacci series. Now, what is a Fibonacci series? So basically, a Fibonacci series is, it is a mathematical sequence, okay, in which the numbers they start with 0 and 1, okay, and then you just keep adding the previous two numbers and you make it. So, for example, it will be 0 and 1. It starts with 0 and 1. And then 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. And it keeps going on in that manner. Okay. It just keeps going on and on. So now in this, there are many ways to ask the Fibonacci series. But first, before we learn any other way, number one is understanding how to code it. So today we will learn the code of a Fibonacci series. Okay. So like we know the output has to be 0, then 1, and then 1, then 2, and then we are just going to stick on so much for now. Okay. Now, we know we start with 0 and 1. So I've given at x the value of 0, y the value of 1. So this is my x, this is my y, this is my x plus y. Okay, so let's say this is my x, this is my y, and this is my x plus. So I will give this the value 0, 1, this will become 1. Next, in my next round, I have to interchange the values. So now my this x plus y will shift to y, so this will become 1. This y will shift to x, so this will become 1. And I will lose this value. Now, if I use the formula again, my next number is x plus y, so this will become 2. Now I will lose this value, shift this over here, so 1. Shift this in the y place, so 2. And I will have a third value over here. Finally, I will have 3, which is x plus y. So just for easy reference, I'm going to name this variable z. Okay, this is exactly what I have done over here. I have taken x as 0, y as 1, which is my initial numbers. And finally, I'm giving the value of z as 1. But if you don't want to give, that's fine. But it's easier if you give it the value because we can start our loops then. So I'm saying to the user, enter the limit. That means up till where should I, you know, up till where should I print the Fibonacci series. So let's say I will tell the question can come in so many forms. Let's say the question is first 5 Fibonacci numbers. Then it will be different. Then it will be uh, probably something like up till Fibonacci numbers up till 50. All the Fibonacci numbers up till 50. Then it will be different. So over here, we are going to print Fibonacci numbers up till a limit given by the user. So if the user says 100, starting from 0, 1, up till you reach 100, you will print all the numbers. The minute the Fibonacci number is more than 100, you will stop. So over here, the user is going to decide the final number where we are going to stop. And so the code is designed in that manner. Now, let's start with this. So I've said x equals to 0, y equals to 1, z equals to 1 because we know 0 plus 1 is 1. This calculation can be done. Then I am just printing the word Fibonacci series, and in the new line, I'm going to print Fibonacci series in one line. We are going to print the Fibonacci series in one line. Okay, so how are we printing it? In print function over here, I am printing x, y, and I'm ending it with a space, and that means the next print will not happen in the next line, it will happen in the same line. So what is my x is 0, my y is 1, x, y. We are printing these two. Then I'm saying while the z, that is the number 1, right now that the value I have given, while my z is less than or equal to the limit, let's say the limit entered by the user is 50. Or let's just say right now, for now, I'm putting the limit as 10. Okay, so what's the value of z? It's less than 10. Yes, so it goes inside the loop and it will print z. That means it will print I. Okay, now we are swapping the values over here. This you have to understand very, very well. Over here, we are swapping the values. What are we doing? Okay. So over here, I have my x. Over here, we have my y. Z, the first time I have given values 0, 1, and 1. Next time over here, when I come, I say x equals to y. So what's the value of y? It's 1. So my next time, my x will become 1. Here I'm saying y equals to z. So my z is 1. Again, then I say z equals to x plus y. So take the new values and I have the number 2. It will go up. It will check. Remember the condition. Z is less than or equal to 10 because the number given by the user I is 10. So is Z less than or equal to 10? Yes, it is less than or equal to 10. So it goes back inside. Okay, it will go back inside. Now, what will it do when it goes in? First, it prints Z. First, we are asking it to print Z, and that also in the same line because we are ending it with a space. So what's the value of Z? The value of Z is 2. We will write 2 over here. Then we are again swapping. That means first x equals to y. So the value of x will become 1. Y will get 2. Okay. How do we swap like this? So 1, 2, z is 3. It goes out, it goes here, and it will check is 3 less than equal to 10. Yes, it is less than equal to 10. It goes inside and we say print Z. So it will print 3. Again, swap will happen. So the 2 will get transferred here. 3 gets transferred here. Z becomes 5. It will go up here. It will check. Is 5 less than or equal to 10? Yes, it is. It goes and it will print Z, which is 5. Okay, after it prints the number 5, again we are swapping. So over here we will get 3. Over here you will get 5. Over here you will get 8. It will go up to check, is 8 less than or equal to 10? Yes, go and print the number 8. All right. And then again it will do the swapping. So now this will become 5. This will become 8. This is going to become 13. It will go here. Is 13 less than equal to 10? No. So it will stop and this will be our output. 0, 1, 1, 2, 3, 5, 8. When the user is going to give the limit as 10. If the user's limit is 20, then 13 will get printed and the number after that won't be printed. Okay. So this is again, right now, this is not a user control loop. It is not required because anyways, the user is controlling the loop by giving the limit. All right. So let's see the output of the program. You have understood. I'm assuming you have understood the understanding of the program. Yes, 0, 1, 1, 2, 3, 5, 8. This is a Fibonacci series. Now, the kind of questions that can come. Number one is the one we have done, where the user will decide the limit. It will decide the limit. Second can be print the first 10 or print 10 Fibonacci numbers. Now, when I say print 10 Fibonacci numbers, it basically means, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. These are the first 10 numbers. So how do we stop this? Because over here, we can't give them a limit. So in this, we will use the for loop. That means over here, we will use the for loop. For I in range 10. Don't use I because it might get confusing to you. Okay, and I'll tell you how we will do this. Everything will change, okay? So write this down. This one is where the user enters the limit. The next one, Fibonacci series that I'm going to show you right now is going to be where the we have to print the first 4 or the first 5 or the first 10. This also can be taken from the user. Let the user decide how many Fibonacci series numbers we want to print. Okay, so let's take that from the user. So enter the number of Fibonacci numbers series you want to print. So 3, 4, 5. Okay, then I'm giving the values X, Y, and Z. And print. Okay, and then over here, I'm going to say for A in range I plus 1. I is, let's say the user says 3. So over here, remember we have to take one more. So 4. Correct? And then you will print XY in one line. Okay, and you will not print Y. This XY you're going to print outside the range. Okay. Yeah. So this is going to work. So in this, what I'm going to do is Again, we are initializing these variables. You're taking the number. So let's say the user says 3. Okay. So over here, this will be the range of 4. So it will run 0, 1, 2, 3. So I will get 4. It will stop at the number 4. All right. Let's see if you feel it's wrong, you can always change this one. Okay. So I'm saying print Fibonacci series. So the word Fibonacci series will come. Then I am saying print X, print Y, because X and Y is going to be printed as it is. And then we are going to leave some space. So we know that in this line, it won't go to the next line. Then I'm saying for A in range I plus 1. So that many times this particular part should run. And I'm printing Z. So 1 will be printed. And I'm ending it. Then I'm doing my swap. Again, going second time printing Z, swap, going in printing Z. Okay, let's run this and see if this works. So let's say 3 Fibonacci numbers, but I'm getting more than 3. Of course, I'll get more than 3 because this is outside the loop, correct? So I have to say probably 2, 2. 3 Fibonacci numbers. I'm getting 4. That means I have to say I over here. 3 Fibonacci numbers, 0, 1, 1. Let's run it again. 5 Fibonacci numbers, I got 5 numbers. Yes, so this is another way that we can ask the same thing, Fibonacci series, but in this the user is going to decide how many Fibonacci numbers are to be printed. And then there is up till where the limit is decided by the user. So these are two different sets of code, but remember the Fibonacci series, the code of Fibonacci series still remains the same. Okay. All right. Now in this, I can even include a while loop. So while the user wants to try, he can try it. So I can have while true. Whenever you do while true, it has to be capital, okay? And then we know we are going to take all this. We are going to indent the regions. It goes inside it. Enter the Fibonacci series. And also I'm going to say press 0 to exit. And the first thing I'm doing is I'm going to check if I equals to 0. Then I'm going to come out of the loop. Enter the number, I'll say 8. Now, the problem here is over here, it's coming in the same line. So over here, I'm going to do new line character, save it. Now I will run it. 8, 10, 100. Yes, say 20. These are my 20 Fibonacci series numbers. And then I press 0 and I exit it. All right. Is this Fibonacci series clear to you all? Okay. So now we will learn one more today, which is prime number or not. Now, what is a prime number? What is a prime number? A number that is divisible only by itself. That means it is not divisible by any other numbers like 2, 3, 5, 7, 11. Okay. So basically it is a natural number that is greater than 1 and it is not a product of two smaller natural numbers, smaller than itself. So if I have to check, if 4 is a prime number, then 4 should not be a product of any two smaller numbers than themselves. But 2 into 2 is 4. So 4 is not a prime number. Okay. But 5 is a prime number because 1, 2, 3, or 4 multiplied by anything does not give us 5. So we are going to use this logic to write the code of prime numbers. Okay. I'll just save this as because this is a Fibonacci series up till code. Number of entries. Okay. Okay. Hello. All right. Okay. So over here now we have a prime number or not. So again, first we will understand the code, and then you will be able to again you will have to learn to apply both prime numbers up till 50 or the first 5 prime numbers. Same logic will be applied. So I'm not going to show you those two codes now. I will only teach you the logic of prime number code, and you will have four codes to practice. Fibonacci series up till first 5 Fibonacci numbers. Both these places, user decides the limit, user decides the numbers. At the same time, prime numbers up till a limit, and the first x prime numbers. Again, both the cases we will take the user. The reason we try practice with the user is, suppose I tell you print the first 5, you can still do the print the first 5 if you have done the user way. But if I teach you only print the first 5, you will not be able to do it the other way around. Okay. So now let's see what we are doing in this code. All right. So over here, we are going to take a number from the user, whatever number the user is going to give us. So we will look at two examples. We will look at the number 4 and we will look at the number 5. Because we know one is a prime and one is not a prime. Now, for I in range, now up till where we are taking? Number 1, we are starting from 2. Because if you take 1, anything divided by 1 will be the number itself. It will have no meaning to it. So we are going to check if if you're getting a product. So we are not going to take the number 1. We're going to start with the number 2. So I'm creating a range. So what will the range be? Over here, I'm writing the range. Where I'm writing from 2 to num, that is 4. Floor division 2 plus 1. This is to bring a complete number over here. Now, 4 floor division 2 means, floor division means what? You all remember floor division. Floor division means, for example, 5 divided by 2 will be 2.5. But 5 floor division 2 will be 2. What will it be? 2. You will forget all the fractional part is ignored. That is floor division. Okay. So if you just look at this part, that is num floor division 2. So 4 floor division 2 will be 2 plus 1. So this will be 3. Over here again, 2 plus 1. Again, it will be 3. Okay. So 2 to 3. Both of them will have the same range, which is 2 to 3. But suppose if I have one more, okay, just for y'all, I'll take one more. Suppose I have 7. So my floor division will be 3.5. So it will be considered as 3. 3 plus 1 will be 4. So it will be 2 to 4 over here. Okay. Understood how these ranges are working over here? Now we are saying if the number, that is 4 modulus I. So first my I is going to be 2. Then it will be 3. 4 modulus 3. Over here I will have 5 modulus 2, 5 modulus 3. And over here I will have 7 modulus 2, 7 modulus 3, 7 modulus 4. All right. Now, I'm saying we are going to check that if it is equal to 0. So when you do 4 divided by 2, do I get any remainders? No, it equals to 0. Okay. So as soon as it comes yes, as soon as this comes yes, we are going to print it is not a prime number and we are doing break. That means this will never happen. We will never go further. Okay, now let's look at the second one. 2 divided by 5. Will I get a remainder? Yes, I get a remainder. So it will go to the else and it will print it is a prime number. It will go back in the loop and it will again check for 3 because it's in the else part. It will check for 3 and again I will get 3 divided by 5 is again true. So I think it should have a break over here again, right? All right. Again with 7, the 7 divided by 2, is it equal to equal to 0? No. So it is again, it will print 7 is not a prime number. It should print it is a prime number. Okay, let's just run this and check first. Yes, it's coming 2 times. It is a prime number. So over here also we should have break. So let's say 6. It is not a prime number because 2 3s are 6. Again, so I want this to keep happening again and again. What do we do? And I'm going to check that first only. Oh, I just realized that you were not able to see the output. Okay. So press 0 to exit and let's put in a number and check. So 6 is not a prime number. 7 is a prime number, not a prime number. 9 is a prime number. 10 is not a prime number. 11 is a prime number. 12 is not a prime number. 13 is a prime number. Okay. 14 is not a prime number. 15 is also not a prime number. 3 5s are 15, no? 15 is not a prime number, right? Okay, that means there's something wrong in the code. We need to fix it. Okay, this is another code which is also very nice. And this also tells us which are the two numbers that mean it is not a prime number. Just see the working of it. So if I'm saying 14, it says it is not a prime number because 2 times 7 is 14. So let's understand how this code is working. It's working on the same logic. Number one, here we are taking the user input. We're taking the user input. Then over here, since prime numbers are greater than 1, you will check if the number is greater than 1. If it's not greater than 1, we go to else. Here my if and else is here. My if has the else over here. So if it's equal to 1, it is not a prime number because 1 is not a prime number. So we are directly printing it is not a prime number. Now moving further, if it is more than 1, we are going to check in a range from 2 to 14, correct? So we are going to go inside and we are going to start with 2 first. So the number that is, let's say the number was 14 given by the user. So if 14 modulus 2 equals to 0, which is yes, which is true, then we are going to say it is not a prime number, and we have the 2, we have the 14, and we are going to print it. Okay. Now, suppose let's say 15, because in 15 what will happen? It won't work with 2. So let's understand this piece of code, which is the most important. So in this piece of code, we first have I, which is a loop control variable that works on a range from 2. It always starts from 2 till whatever the number user has told us. So 2 to 15 or 2 to 14, whatever. The next thing we should know is the num, which will remain constant. It does not change. It is the one that the user has given us. That is 15. All right. So just using these two, we are going to do our calculations. The first time we run, I is going to be 2. We go inside and uh, we have a formula which is num divided by I equals to 0. Should give you a remainder of 0. So let's look at this scenario now. The first time I is 2, this is 15. So we say 15 upon 2 equal to 0. No, it does not equal to 0. So it does not equal to 0. So it will not go in this loop at all. Correct? Now remember, this for ka this else is there. This if does not have an else. So if 15 does not equal to 0, it's just quietly going to go inside the loop again. This will become 3. This will remain the same. Then we say 15 upon 3 equal to 0. 3 ones are, 3 5s are 15. Yes, when you divide it, you are not getting 0. So you will go ahead and it will become, it will work. It will say it does not equal to 0, which is true. So it will go inside and also print it's not a prime number. I will be 3. 3 times num divided by a floor division I will give me 5. 3 times 5 is 15. So it is not a prime number. Let's run this and see. 15. 3 times 5 is 15. So 15 is not a prime number. Understood this? Okay, looking at the same thing, looking at our old code, this should be here. Okay, this was the only problem in our code. And so we don't need an extra break. Let's see if this works now. 15 is not a prime number. 14 is not a prime number. 7 is a prime number. Basically, inside this for loop, we are going to run the range from 2 to floor division. So like 50%, I think 50% plus 1, you can say. Okay, you're going to run the loop and you are going to check for each and every number. You're going to divide with each and every number and check. So if it's 14, Okay, so you're going to check 7.5. So 8, from 2 to 8, each and every number will be divided by 14. It will be 14 divided by 2, 14 divided by 3, 14 divided by 4, 14 divided by 5, 14 divided by 6, 14 divided by 7, 14 divided by 8. Basically, this is the logic. You're going to check each and every. And one of these, even if one of these you are able to, do even one thing. So let's say 2 by 14, 2 sevens are 14. So remainder is 0. This is true. So it will say it is not a prime number. But if you look at, if you look at 15, so 15 divided by 2. So if you do 2 and 15, 2 sevens are 14, 1 carried forward. So it will not go here. It will not go inside. It will not print. It is not a prime number. It goes back up and it will check for 3. 3 divided by 15. 3 fives are 15. 0 remainder. So it goes inside and it prints. It is not a prime number because of 5 and 15. 3 and 15. Understood the second code I was explaining over here? So you can use any of the two codes, but this is the most important thing that you have to learn. Okay. So with this, I'm going to end. I'm going to end today's class. A little longer class, but we have learned two codes today: Fibonacci series and prime numbers. Next class, we are going to do place value. So, again, it will be a little longer class, but I want you all to understand this concept very, very well because these are the ones that will come in the examinations. All your examinations, these codes have to be understood, not learnt. Please sit and understand them. The easiest way to understand these codes are: number one, practice. Number two, wherever you feel there's a doubt, I didn't understand what happened over here, use a print statement to see what variable value is at that point. Use an extra print statement over there in the middle wherever you feel I didn't understand what happened over here. Okay. So whenever you will use your print statements, you will be able to understand the value of that variable inside the computer memory. So with this, I end today's class. Sorry for the long class, but prime numbers is again important. You all have four programs to practice: Fibonacci and prime, and in both of them, limit entered by the user and the number of prime numbers entered by the user. You should be able to print both. With this, I end today's class. Next class, I will show you both those programs of prime and we will start with the place value system. Okay, with this, I end today's class. Stay home, stay safe, take care, keep learning. Thank you.